Hello everyone and welcome to another SQL video with Learn at No Star. Today we are going to discuss 10 scenario-based SQL interview questions which have been asked in Amazon SQL interviews. So let's get started. So the first question is to calculate a running total of quantity sold per product in each month. We have been given a sales table which has the quantity by each product and the sale date on which the sale was made. Now this is a relatively easier interview question and all we need to do is use the window functions to find a running or rolling total. So let's first select the product ID, and since we need to find the sum for each month, we are going to extract the month from the sale date. Then to calculate the running total, we simply need to use the sum aggregate function and sum on the quantity over partition by the product ID and month of sale date as running total from a sales table, and we are just going to order by sales date, so it makes sense when we look at the results. And we're also going to include the sale date here. Remove the S, and this should give us the running total. So we are just going to execute this query, and let's include the product ID as well in our ordering so that it's easier to understand the results. So executing this again, we can see that for product ID 1, month 8, this is your running total. For product ID 2, this is your running total, and similarly for product ID 3. Now we see that the data that we have is only for 1 month. So let's update the data a little bit to have multiple months and then run this query and see the results. Now if we run this query, we can see the running total by product ID and month. So for example, for product ID 2 for the month of July, the running total was 3, and for the month of August, the running total was 4, and so on. Let's move on to our next SQL query. The question is to identify the maximum number of consecutive login days per user. So we have been asked to find the consecutive login streak. So this is similar to the gap and island problems which are asked in many SQL interviews. The data that we are given is the user data and the activity date on which that user logged in. So the first step that we are going to do is we are going to create a row number for each activity date on which the user logged in, and we are going to order it by the activity date. So let's select the user ID, the activity date, use the row number function to generate the row numbers over, and we're going to partition by the user ID and order by the activity date. We can just call it as row number. So if we execute this query, all this is going to give us is a row number which is in the order of the login activity dates for each particular user. Now we are going to use this data set that we just got for the next query that we're going to write on top of this. So we are going to put this in a CTE and use this for the next query. So the next query is going to identify the groups. So the groups on the basis of consecutive logins for each user. So to do that, we are going to again select the user ID. And the trick here to identify the group is to subtract this row number that we generated in the earlier query from the activity date. So we are now going to subtract 1 day from the activity date of 1st August 2023. Similarly, for the second record, we are going to subtract 2 days from the activity date of 2nd of August 2023. So let's implement that, and once we see the results, you will understand how it has been used to identify the groups. Now to subtract a day in SQL Server, we need to use the date add function. We need to specify the interval as day. And because we want to decrease the day, we are going to use -1 into the row number from the CTE where it was generated, and then we are just going to use our activity date column and call it group from the earlier CTE that we generated. So CTE underscore RN. Okay, so for understanding the results, let's also include activity date as a column, and then we can look at the results. So I'm going to execute this query now, and we'll see that a new column group has been added to our data set. And if we look at the values, so let's start looking from record 1. So user ID 1, activity date was 1st of August. Then he logged in on 2nd of August and 3rd of August. So he logged in for 3 consecutive days. We had the row numbers generated for these 3 activity dates as 1, 2, and 3. So we subtracted those many days from the activity date. And when we subtracted those row numbers from these activity dates, we reached back on the same date for each of these 3 records, which means that these 3 are a group, which means they are consecutive logins. Now let's check for user ID 2, because he logged in on the 1st of August, but then he didn't log in on the 2nd, he logged in on the 3rd. So there is a gap here. So did we correctly identify the gap? Let's see. So for this record, the row number generated was 1, and we reached back on 31st of July. For 3rd of August, the row number generated was 2. So we subtracted 2 days from this date, and we reached back on 1st of August, which is a different date from the 31st of July that we have here. So these are 2 different groups that we have identified. And similarly for the other user IDs. Now we are going to put this under a different CTE as well. And we are going to write our next query on top of this CTE, which is the last query, which is going to identify the groups and the length of these groups. So we are going to select the user ID. We are going to do a count to get a streak length from our group CTE. And then we are going to group by the user ID and this group column that we have over here, and execute this query. And you will see that user ID 1 has a streak length of 3. So he logged in for 3 consecutive days at a single go. User ID had 2 different streaks of 1 day each, and user ID 3 had a single streak of 1 day. Sometimes they may also ask you to find the start and end of the streak. So you can find the minimum activity date as start date, max of activity date for each streak as end date. And when you execute, you will get the start date and end date for each streak as well. Now this question has to be the most commonly asked SQL interview question in almost all interviews which are intermediate level and above. It could be asked in the form that we are going to solve today, or it might be there is some other variation of this question, but it will be asked in some form because it uses the window functions and it allows you to calculate the nth value per department or per category. So the most common variation of this is to ask how to find the 3rd highest salary per department. We will be given an employee table with the department IDs and salaries within that department for those employees. And all we need to do is use some Windows functions, the ranking functions, and we can easily find the answer to this problem. So the important thing to decide here is probably deciding which of the ranking functions you're going to use. Are you going to go with the row number function, the rank function, or the dense rank function, which is most appropriate for your requirement? Now, the difference, you have to understand the difference between how those ranking functions work. So the row number functions will generate the row numbers irrespective of any tie values. So if you have 2 records with the same salary, it will generate a row number of, let's say, 1 and 2 for them instead of giving a row number of 1 to both of them. The rank function will generate the same rank for the same value. So it will generate the rank of 1, 1. But then for the next salary, it will skip the value of 2 and directly go to 3. For dense rank, it will generate the same value for ties, but it will not skip the rank for the next value. So the most appropriate in our scenario is going to be dense rank. And the next part is simple. You just need to define your dense rank function over the right partition. So the partition is going to be the department ID, and then we are going to order by the salary. And here again, you have to keep in mind that you have to order the salary in a descending manner, because we are talking about the third highest salary. So you have to go from the highest to the lowest. So these two things you have to keep in mind, which ranking function to use and the order in your partitioning in your Windows frame. And then we call it as rank. Now, if you execute this, you will see that you have department ID 1, you have 1, 2, 3, 1, 2, 3. Now, only thing you need to do is pick up the third highest salary. So again, we are going to put this result in a CTE, and then we are going to select, I'm just going to select star, but you need to just select whatever columns you need in your answer. And for an interview, it is better to specify the column, because selecting star can have performance implications. Okay, so select star from the CTE rank, where rank equal to 3. Execute this, and you're going to find out the third highest salary. Now, this next SQL question, it might look complicated, but it's really very straightforward and easy. So the task here is to find all the users who have purchased every product. You have a user table, a sales table, and a product table. So the product table will have a list of all the products, and then we have the sales table in which you have every transaction, every order for the user ID and the product that the user bought. So what we're going to do is, first we are going to select the user ID from a sales table, and then we are going to group by the user ID, and then we're going to add a filter to this query. So since we have user group by, we are going to use having. We are going to do a count on the distinct product ID that each user bought, and we're going to compare it with the total count from the products table. So we can see that there are 3 products in our sample data in the product table. So any of the user who has bought 3 distinct products has bought all the products from the product table. So this is in the simplest form. We are assuming that all the products that the user bought in the sales table have to be the products from the product table. So now if we execute this query, we get the answer as user ID 4. And then if we go back and check the data for user ID 4, we can see that user ID 4 has ordered all 3 different products from the product table. Now, this next question is also asked in many interviews, popularly by retail organizations, where customers place orders and there can be duplicate orders. So the task here is to identify the users who place more than one order within 1 minute. We are given a table which has the order ID and the order time. So again, the solution for the SQL query is very simple and straightforward. It looks complicated, sounds complicated, but it is not. So let's write the query. So what we're going to do is, first of all, we are going to find out the previous order time, so the order time from the previous record for each user, and then we are going to compare the difference. We are going to calculate the difference between those 2 consecutive order times and see if it is less than 60 seconds or not. Now, to find out the previous order time, we can easily use the lag function. So lag of order time over partition by user ID and order by order time, as let's call it previous time. So now just execute this part and you'll see that you have the previous time. So now all you need to do is calculate the difference in seconds between the order time and the previous time. Now I always like to put these queries into a CTE, where we need to write queries on top of any result data set that we got from a previous query. But there's another way we can also treat this as a subquery. So just for this example, I'm going to treat this as a subquery so that we are aware that this is another way of writing the query. In terms of performance implications, they both will be treated the same, but the CTE is more readable and easy to understand. So we are going to select the user ID, order ID, order time from this subquery that we created over here. We need to give it a name, previous, and then we are going to put a check by using a where clause. And to find the difference, we are going to use date difference. The interval that we want is second. The difference between the previous time and the current time. So previous time and order time is less than equal to 60. Now, if you look at the data, we can see that we have one scenario where there are duplicate records. So you can see here the order time is 10 o'clock and 30 seconds. And here in this, the previous order time was 10 o'clock. So there's a difference of 30 seconds. So this is the record we're looking to identify. So let's run our query and see if it gets identified. And this is the one that will get identified. Now the next question is a common requirement for companies, which is to rank the products by revenue in each quarter. So we're given a sales table and we have the revenue calculated. There might be scenarios where they will ask you to calculate the revenue. So you need to put a simple formula like the quantity, the units sold into price for each unit to calculate the revenue. But here the ask is to rank the products based on the total revenue in each quarter. So the first step is to find out the total revenue in each quarter per product, and then we have to rank them accordingly. So what we're going to do is select the product ID. Now we have been given a sale date, so we will extract the year and the quarter from the sale date. So year from sale date as year. And now we are going to use a date function called date part to extract the quarter. So we are just going to pass it quarter of the sale date. Call it as quarter. And then as simple as summing the revenue. Call it total revenue. And group by the product ID. And then we need to group by product ID and the year and the quarter. Execute this and you'll get the total revenue by the year and the quarter. Now we need to rank these products by the total revenue. So again, we are going to put this in a CTE. So with CTE revenue as this. And then just doing a select star from a CTE and adding a rank over partition by the year, the quarter, and then order by the total revenue in a descending manner as rank. So if you execute this now, you will get the ranking for the revenue. Now the next question, again a very common interview question, more advanced level SQL skills, because we are going to use the recursive CTEs, and the question is to find out the organization chart. So any kind of question that deals with employee manager hierarchy or family hierarchy, you need to use recursive CTE and then you can generate the whole hierarchy. So in our case, we are going to generate the full reporting chain for each employee. And we have been given a table called employees, and you can see you have the employee ID and the manager ID for each employee. Next, what we need to do is to build a recursive CTE for the organization chart. So we are going to call it organization chart. And for each recursive CTE, there are two components. You have the anchor and then you have the recursive component. So the anchor member is going to be the top level managers. So the managers at the top who do not report to anybody else. So let's start building that query. So we are going to select the employee ID, the name, the manager ID from the employees table. And since we are talking about the top level managers, we are going to say where manager ID is null. Now let's move on to the next component, which is the recursive member. So employees reporting to any of the managers above them. Now to find out this relationship, we need to use self-join. So first of all, we are going to pick up the same things that we picked for our base query. So let's just copy this. And we are going to say from employees, we're going to give it an alias called EMP. And we're going to add that alias over here to each of the columns. And now we are going to perform an inner join or self-join with the CTE that we just generated. So organization chart, we call it, on employee table, the manager ID from the employee table is equal to the employee ID from the CTE that we are generating. So OC.empID. So now this is a recursive CTE which we are going to use to generate that employee manager hierarchy. But we also need to display the whole hierarchy in terms of putting the employee name, then the manager on top of it, and so on. So we are going to add another column over here to both our anchor and the recursive part of the queries. And we are going to say cast name. And since this is going to be a big string, we are going to cast it as varchar max and call it as path. Now what we are going to do for the recursive component to add the manager name to that employee ID name, we are going to again put a cast. We are going to pull the manager name from the CTE. We are going to concatenate it with an arrow sign, and we're going to add it to the employee name from this recursive part of the CTE. So emp.name, again we are going to cast it as varchar max and call it as path. Now all we need to do is do a select star from our CTE, execute. And this is the result set that we are going to get, which is going to give us the top level manager, then the employee reporting to that manager, and the whole hierarchy. Now this is another popular question, and it asks us to identify the customers whose revenue increased month over month. Again, if you just split it mentally into parts and steps, this is very simple. The query actually is very simple. What we need to do is find the total revenue for the current month, total revenue for the previous month, and then find out the difference. Just find out whether the total revenue for the current month is greater than the revenue for the previous month. So all we need to do is select the customer ID. Again, extract the year and the month from the order date, sum the revenue, and group by and the customer ID, year of order date, and month of order date. Execute. You'll get the total revenue for each customer for each month. We're going to put this again in a CTE. Now what we're going to do is we are going to create another CTE, call it previous revenue, and use the previous CTE to calculate the revenue for the previous month for each customer. So to do that, we are going to use the lag function, and we are going to partition by the customer ID again, order by the year and the month as previous revenue. So now this CTE previous revenue has the total revenue as well as the previous revenue for the revenue for the previous month. So we are just going to do a select star from CTE previous revenue. Let's see what are the results. So you can see for each customer, you have the revenue for the current month and from the previous month, so 700, 500. And we need to identify the customers whose revenue increased month over month. So wherever the total revenue is greater than the previous revenue, those are those customers whose revenue increased. So that is what we need to identify. So what we're going to do here is add a where clause where total underscore revenue is greater than previous underscore revenue. Execute this again. So these are the customers whose revenue has increased month over month. Now this next one just tests your knowledge of the financial mathematical functions that can be used for financial analysis. So medians, modes are very common for analysis. So what they have asked us is simply to find the median revenue per product. So calculate median revenue per product. We have been given a sales table. We have the product. We have the revenue. So here to answer this question, the first thing that you need to understand is that what is a median? So a median is mathematically defined as a middle value in a sorted data set. Now, since we need to find the median for revenue, that means we need to sort the revenue, and it is per product. So the revenue for each product, we need to sort it and then find the middle value for that. Another thing that you need to be aware of, that there is a window function called %_cont, continuous percentage, that can be used to find out that middle value, and because it can be defined as the 50th percentile. So what you need to do here is simply use that function. So %_cont, pass 0.5 to it to calculate the 50th percentile. You need to know the syntax of this function. So you have to define it as within group. Then you have to define your order. So we are going to order by revenue. And since it is a Windows function, we need to define a Windows frame. So partition by product ID. And then we are going to call it median revenue. If you execute this query, you will get the median revenue for each product. But since it is a window function, you got each input record in the output dataset as well. So what we are going to do now is use a distinct so that we get only distinct records for each product. So product ID and its median value. So execute and you'll get the median values. So the last question that we're going to solve today is to detect the audit gaps or to find the dates in a month when no sales were made. Now all these kind of questions, sales questions, order questions, are very important for retail organizations like Amazon. So this is one of the commonly asked question there. So what you need to do to solve this question is, first you need to have a calendar table. If you don't have the calendar table, you need to generate a list of continuous date values. So let's say our sample data set is for August 2023. We need to have all the 31 dates for August 2023. There are different ways in which you can generate this entire list of dates. Recursive CTE is the most common and simple way. So what we can do is we can define CTE as all dates as. Here what we are going to do is define a first day. So I have defined 1st of August 2023 as a first day. That becomes the anchor component. Then we are going to define the recursive member. So union all. And now in the recursive part, we are going to increment this original date value by 1 for each iteration. So we are going to use the date add function. We're going to add by 1 day. So 1 day to the sale date from the anchor part. And this is a recursive CTE, so it is going to reference the same CTE. And then we have to define the limit, the stop limit on this CTE. So where sale date is less than 2023-08-31. So this is one way in which you can generate a continuous list of date values. Now we are going to identify the dates for which we have the sales data. So CTE sales as select distinct sale date from sales. Okay, so before we write the final query for this scenario, let me just do a select star from the CTE all dates that we created to show you that it generated the list of all date values, 31 values. So you can see there are 31 rows generated from the 1st of August all the way till the 31st of August. Okay, so now we are going to perform a join between all dates and the actual sale dates and find out the dates where no sales were made. So select sale date from the CTE all dates. So let's call it 80 and give the alias here. And then you're going to left join this with the CTE sales, which has distinct sale dates for the actual sales. Let's call it S on AD dot sale date is equal to S dot sale date, where S dot sale date is none. So what we are effectively doing here is we are doing a left join between all dates and the sale dates, and where the sale date value is a null from the actual sales date, that is the date when no sales were made. So now we're simply going to execute the whole query, and the output that we're going to get is all the dates when no sales were made. So quite a few days when no sales were made. So these were the 10 interview questions which have been asked in actual Amazon SQL interviews for data analysts and data engineers and data scientists. I hope they were useful. All the SQL queries and the data sets are provided in the link in the description, so you can check them out. I hope the video was useful. Please do not forget to subscribe to our YouTube channel. We'll see you in the next video. Thanks a lot for watching. Bye.